Hello, my name is Dr. Alexandr Simonov. I work at Monash University on the global challenge of converting renewables into their fuels and useful chemicals that we can use in our everyday life. Our current electricity resources are majorly satisfied by the fossil fuels, which utilization not only emits carbon dioxide, which is a greenhouse gas, but they are also quite limited in resources, and quite soon we will run out of the significant amount of these fossil fuels. At the same time, next to us, there is a wonderful and essentially infinite source of energy, which is called sun. Moreover, on our planet, we have constant winds and waves, which we can transform into electricity and use it essentially indefinitely. However, they are intermittent in nature, which means that this electricity will not be always available. Hence, a more convenient approach is to further transform this electricity into energy of the chemical bonds. And this means just transforming electricity into fuel, which we can use in a normal way. A more conventional way to store electricity, including renewable electricity, is to use battery technologies. At the same time, batteries and the electrosynthesized fuels should not be considered as competitors. Among the green fuels, there are also different options, including hydrogen, ammonia, and carbon dioxide reduction products, and each of them will have their own application niche in the future, including the long-term storage or the long-distance transportation. Development of all of these technologies obviously requires deep fundamental understanding of the modes of operation and evolution of the key materials responsible for the transformation of electricity into the target products. To achieve this understanding, we need advanced characterization techniques, which often use such particles like X-rays and neutrons, which we shine on top of our samples, and then, depending on the mode these particles interact with our materials, we can say what is their composition, what is their structure, and how do they evolve during their operation. This particular mode of analysis, which is called either in situ or operando, is particularly useful, and that's what we often do when we study our processes.